In this video, we explain the three-dimensional geometry of class 11 of ICSE board. Okay. If the coordinates are in three dimensions, that means x-axis, y-axis and z-axis. And for example, there's a question, find the distance from origin of this point and this point. Okay. So we have to find the distance from origin. That means we know the coordinates of origin is 0, 0 and 0. This is for x coordinate, this is for y and this is for z coordinate. So our distance formula is x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. So when there is three-dimensional geometry, we just apply for all the three coordinates. So what we get, distance from the origin, we get 2 minus 0 square, 2 minus 0 square, similarly 3 minus 0 whole square. So ultimately what we get, 2 2s are 4, 2 2s are 4 and 3 are 9. That means we get under root 17. Similarly, you can also do this question by your own. Now, for example, there's another question. If we have to find the distance between 2 points, let it be these 2 points are here, P and Q. And we have to find the distance between these 2 points in three-dimensional geometry. Find the distance between P and Q. So, this is x1, this is y1, this is z1. And origin is not there. This is x2, this is y2, this is z2. So we just simply apply the same formula. That means x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So when we apply, what we get? Minus 4 minus 2 whole square minus 3 minus 2 whole square minus 2 minus 3 whole square. So when we solve, we get minus 6 square minus 5 square minus 5 square. After solving, we get the answer, that is 36, 25, 25. That is 50 and 36, that is under root 86. So this is the distance between 2 points when they are in three-dimensional coordinates, when all the three-dimensional coordinates x, y, z is given. Now this is the type of the question, and we have to show that these 3 points are collinear and they have their values in all 3 directions x, y and z, and we have to see whether these points are collinear or not. What are the collinear points? If they lie in the same straight line, we can simply find it by using also the determinants 1, minus 1 and 3, then 2, minus 4, 5, then 5, minus 13 and 11. If the value of this becomes 0, then these 3 points are collinear. How can we solve it? We take it as 1 over here, then cross multiply of this channel, minus 4, 5, minus 13 and 11. So minus 44 minus 13 5s are 65, minus 65. Clear? Now, before writing minus 1, we put minus sign again, minus of minus that one, that is minus minus plus 1. Now, for this, we take the 2, 5, 5 and 11. Okay. Now, firstly multiply 11 2s are 22. Put the minus sign. 5 5s are 25. Now, the next one, we have over 3. For the 3, we just leave 5 and 11 and we have the block 2 minus 4, 5 and minus 13. Now, 13 2s are 26. Then minus 4 5s are 20. Now we solve this, and if this becomes 0, then the points are collinear, otherwise not. So what we have, minus 44 plus 65. Next one, 22 minus 25. Next one, 3 minus 26 plus 20. Okay, now we solve it. What we have? We have 1 into 5 minus 4, that is 1, 6 minus 4, that is 2, plus it is minus 3, plus 3, it is minus 6. So we have 21 minus 3 minus 6 3s are 18. That means 21 minus 21, and it comes out to be 0. If the determinant of all the 3 points is 0, then the points are collinear. If we have to prove whether it is isosceles, whether it is equilateral, we have to find the distance between all the 3 coordinates. I can also show you some examples. Show the points A, B and C are isosceles. That means this is the triangle and we have 3 different points. And we have the point 3, 5 and minus 4. And here we have the point minus 1, 1 and 2. Here we have the point minus 5 and minus 2. And we have to find whether this triangle is isosceles or not. For this we have to find the distance between these. That means distance from A to C, A to B and B to C, one by one. Okay. Firstly I am going to find the distance between A, B. Okay. We use the same formula. That means 3 plus 1 whole square, 5 minus 1 whole square, minus 4 minus 2 whole square. What is it? 3 plus 1, 4 whole square, 5 minus 1, 4 whole square, and this is 6 whole square. Ultimately we get 4 4s are 16 plus 16 plus 36. And we get 32 plus 36, that is 6 to 8 and 68. Here, so distance from A to B is under root 68. Now we find out the distance between B to C. Now we get minus 1 plus 5 whole square plus 1 plus 5 whole square, 2 plus 2 whole square. So we get 4 whole square, 6 whole square and 4 whole square. And again what we get under root 68. You can also find the distance between A and C and observe the pattern. From here we get both are under root 68. Ultimately it shows that these are the points which represents an isosceles triangle. And similarly you can also find out whether they are Pythagoras theorem, whether they are equilateral triangle or not. I think you are big enough to find out the different things. Now just observe this question. Derive equation of locus of a point equidistant from this and this. There is a point which is equidistant from this and this, and we have to find the equation for the locus of that point. In such cases, we assume there is a point x, y and z which is equidistant not only from this point, also at this point. Okay, so we just use the distance formula, taking x minus 1 whole square, y plus 2 whole square and z minus 3 whole square, which is equal to what? The distance from this point, that is x plus 3 whole square, y minus 4 whole square and z minus 2 whole square. And we simply equate both of them, taking the locus point x, y and z, and nothing to worry about these questions. Now removing under root square, so what we have? X minus 1 whole square, y plus 2 whole square, z minus 3 whole square. And here we have x plus 3 whole square, y minus 4 whole square plus z minus 2 whole square. Now solve this, we get x square plus 1 minus 2x, y square plus 4y, z square plus 9 minus 6z, which is equal to, here x square plus 9 plus 6x, y square plus 16 minus 8y, z square plus 4 minus 4z. X, y, z both are get cancelled. Okay. Now we have minus 2x plus 4y minus 6z. Okay. Now this is plus 1, this is 4. 4, 1, 5, 5, 9, 4, 1, 5, 9, 5, 14. And here what we have? 6x minus 8y minus 4z. Now 9, 4, 13. 13 or 16, that is 29. Take it on one side. So what we get? 6x minus 2x, that is plus 2x, minus 8y, minus 4y, minus 4z, plus 6z, plus 29, minus 14. Okay, we take all the quantities which are on the left side to the right side and solve it. So what we get over here? We get 6x plus 2x, that is 8x, 8y minus 4y, that is 12y. This is plus 2z. And here we have 9 minus 4, that is 5, and 2 minus 1, that is 1. So this is the required equation of locus. This satisfies our question. So if there is asked find the locus of the point, so never be confused, take it as x, y, z and just go through the condition which is given in your question.